Insulation materials are struggling to meet the demand of modern energy and transportation needs. Thermalytica has created a unique insulation material that is a solid with liquid-like properties to tackle these issues. So Rudder, your innovation, thermal insulation, inflatable solid air, TIISA as you call it, is a new material that's able to have a very wide operating envelope from very low temperatures to very high temperatures and offer amazing insulation benefits. It's very complicated what you've built. Can you describe how the material came together?
To achieve very good insulation performance, usually we need to trap air. So compared to traditional insulation materials, we engineer TIISA to be a composite material to contain large cavity. So basically we work on try to minimize the intrinsic thermal conductivity of the solid part, but then we reach the limit. So we have to work on the structure itself. Yes, and the idea is that once we minimize the solid concentration and maximize the cavity, then we end up with a liquid-like solid state material.
And the TIISA materials have, even though they're a solid, they have liquid-like properties. What are some of the liquid-like properties that give it an advantage?
If you look at other applications, in transistors, we can switch between 0 and 1. In electrochemistry, we can migrate ions, so for example, in the lithium-ion batteries. For insulation materials, usually, we just stay with one single insulation performance. So with this liquid-like performance, we can tailor, so we can dynamically manipulate the presence of the structure of the material, so that sometimes we need insulation, we can make an insulator, and if we need to make a material with high heat transfer coefficient, we can manipulate the structure.
So you're customizing it for the specific application.
Yes.
What are the applications that you're most excited about?
On a large scale, we are excited about using TIISA for global liquid hydrogen logistics. So in Japan, hydrogen is considered as one of the most important energy source for the future. Yes, so to replace the fossil fuel, of course.
As a national mandate.
As a national mandate, yes. And the idea under this project, of course, this is not confined, it's just not limited to Australia. But right now, we're actually doing a pilot test to bring liquid hydrogen from Australia to Japan. And that is a 16-day journey to transfer liquid hydrogen. And we need to have a very good insulation material which can be used at very low temperature.
Because of course the liquid hydrogen boils off at a very low temperature, so there's an enormous loss if it's not being insulated well en route.
Yes.
What percentage savings of liquid hydrogen does TIISA offer versus the traditional insulation method?
This depends on the actual environment or testing conditions, but we believe that we can save as much as 20 to 30% compared to other existing insulation performance.
And you're also using TIISA in paint, in residential paint applications. Yes. For insulation. What are the benefits you're seeing there?
When we apply insulation paint to buildings, commercial buildings or residential buildings, we can reduce the energy associated with heating in the wintertime by about 16%, and the energy associated with cooling in the summertime by about 26%.
When you think about the future roadmap for TIISA and how you go to market, what are the distribution avenues you're assessing and exploring?
We are actually targeting the decarbonization market within the very large, the so-called green energy market opportunity. Yes, and of course, TIISA, we consider TIISA as a platform technology. It is not a material that we use to compete with other important players, for example. Rather, it's a platform technology that we would like to offer to other businesses so that they can take benefit of using this material to make their products more competitive, in terms of making the product more with higher performance, for example.